This time we're talking about the domain of composite functions. As our first example, we're going to look at find the domain of f circle g if f of x equals 1 over x and g of x equals 2 over x minus 1. Now the way this works is the following. First you look at the function that operates first. In this case, f circle g, g is going to operate first. So I'm going to look at the domain of it first, because the x, this number that I'm going to look for f circle g of, is going to go into g first. So I look here and I see, okay, x can be anything except 1, because that would make that denominator 0. So the domain of g, that's a g, the domain of g is going to be all x's except x cannot be 1. So that takes care of the numbers going into g. Now, the numbers going into f are going to be the result of going through g. So actually, the domain of f is going to be made up of the results of g. So our g of x, our y values for g, our results of g, are going to go into f. So therefore, I've got to look at f and see, alright, let's see now, the numbers that are going into here. This number cannot be 0. So therefore, g of x could not be 0. Not x itself, but g of x, because that's what's going in here. So, I look at this and I say, okay, is there a number that I could plug in for x that would make this result 0? And in this case, there is none. The numerator is 2. And so therefore, there's no way for this result to be 0. So the domain of f is going to be all x's, so to speak. So, the result of all this, the overall domain of f circle g is going to be the intersection of these two, which is set of all x's, and the only exclusion is 1. So x can be any real number except 1. So that's the domain of f circle g in this example. Now let's look at another example. In the second example, find the domain of f circle g if f of x equals 1 over x plus 2 and g of x equals 4 over x minus 1. We're going to do it the same way. Now notice I wrote f circle g. If I had written g circle f, I would have looked at f first. Because remember, we're going to look at the function that operates first. In this case, g operates first. So I'm going to look at g. So the domain of g is going to be all x's except 1 again. So x cannot equal 1. Now I'm going to look at f. Now remember, what's going into the domain, what's going to make up the domain of f, is going to be the results of g operating. So this is going to determine the domain of f. Anything that would make, in this case, if you look at the domain of f here, the domain of f says that the number plugging in here cannot be negative 2. Why? Well, because negative 2 here would make this denominator 0. But it's not x. The number going into f is g of x. So what I'm saying is g of x cannot equal negative 2. In order to find out what value would make that negative 2, what I've got to do is set g of x, 4 over x minus 1, equal to negative 2, and solve. In order to solve this, I'll multiply both sides by x minus 1. So I get 4. When I multiply both sides by x minus 1, we get this And of course, in this case, they cancel out. So I get 4 equals negative 2x plus 2. Now solving for x, subtracting 2 from both sides, I get 2 equals negative 2x, which means x equals negative 1. So what this is telling me is that if I try to put negative 1, if I use negative 1 in here, I'm going to wind up with an answer of negative 2, and that will make this 0, which means I won't be able to complete the function of f circle g. So the answer to the question, the domain of f circle g in this case is going to be all x's except x cannot be 1 from up here. Also, x cannot be negative 1 from right here. And that is the domain. So that's how you get the domain of the composite function. You first look at the function that operates first to find your exclusions. Then you look at the results of this to find your exclusions from the second function to operate.